So our last section here, our last part of section 11.4 is going to be about cylinders and cones. And really just kind of terminology here, understanding the difference between a cylinder and a cone versus a pyramid and a prism. So a cylinder is a simple closed surface that is not a polyhedron because its bases or its sides are not polygons. And it's formed as a segment AB parallel to a given line, and the outside edges are a curve, like what we would think of as a smooth curve. So again, the primary example that we would see, we've used this now a couple times, is talking about a can of something. A can of vegetables, a can of whatever you might buy that is canned. They are typically in a cylinder shape. If you were to buy a thing of Pringles, a container of Pringles, well, that container is a tall cylinder. Top and bottom both are circles. It doesn't have polygon sides. It's a smooth surface for your side. In the last video, we talked about nets. If you were to take the net of a cylinder, well, the sides are going to be a rectangle. And then you would have a circle on top and you would have a circle on bottom where they would fold down or fold up, and then that cylinder or that lateral surface is going to be a rectangle. It would just wrap around. And so you probably can picture that if you were to take the paper off of a can. So let's say you go in your cabinet and you find a can of vegetables and you open that and then you take the paper off the side. If you just split it and then roll it out, it's a rectangle every single time. And so for a right cylinder, which you see here in this first example, that lateral surface is made up of, it's just a rectangle. Again, every single time that's going to happen. And so when we think about that, we could have what we call an oblique cylinder, where that top part has been shifted over. Again, we don't see this a ton in, containers that you might buy at the grocery store, but you could see that where the top and the bottom are shifted over. They're not directly on top of each other. It's what we call an oblique cylinder. Very similar to what we have with an oblique prism. We talked about a right prism where the top and bottom are directly on top of each other. An oblique prism is where it's been shifted over. Same thing here with the cylinder. And we typically think about a cylinder as being a circular base, but it doesn't have to be. In this last example here, you can see that the top and the bottom are not circles. Now, they're not polygons. They are still a simple closed surface, but it's not a polygon. And so that would form a cylinder. This one happens to be oblique because, again, the top is shifted over. My kids have some kind of toy they picked up as a souvenir somewhere, and its base kind of looks like this. And it's the same base on the bottom, and then, of course, it's connected. And so there's no way I could draw that same shape again. I'll try. But anyway, so the top and bottom are the same. It's a cylinder, but it's not a traditional can shape where you have a circle on the top and bottom. And so just kind of be aware of that. Our cylinders just don't have a polygon. It has a simple closed surface or simple closed curve as its base, but it doesn't have a polygon. And then a cone is our last part. And a cone is, again, typically thought of to have a circular base. And again, you can see the definition there. It's the union of the line segments connecting a point P with each point of a simple closed curve, the simple closed curve, and the interior of the curve. That's kind of wordy. You can see what a cone looks like. You know that if you were to go buy an ice cream cone and you were to flip it over where the part the ice cream goes in is on the bottom, well, it comes up to a point, right? It looks very similar to this first example. And so, again, you have a lateral surface that is not going to be polygons. It's going to be a smooth curve. The base is also a simple closed curve, but it's not a polygon. And then it has a vertex at the top. Now, notice in a pyramid, that point at the top is called the apex. In a cone, it's called the vertex because it's the only vertex. There's only one vertex here. You don't have vertices, for example, around this circular shape, this circle at the bottom, right? So, because there are no other points, we refer to it just as a vertex. In a pyramid, there's a bunch of vertices, and so the one at the very top that's above the base is the one we refer to as the apex. So just be aware of that. That is a little bit different terminology. Now, again, we think about a cone. I think of like an ice cream cone or like a birthday hat. If you were to, a cone-shaped birthday hat, those are our standard cones that we would think about. But that base doesn't have to be a circle. It could be this type of shape where it's still a simple closed curve that's not a polygon, but it's not but it is still going to fit into this definition of a cone. Now, if our vertex is shifted over and not directly over the center, then it is considered an oblique cone, like both of these last two examples. The first one is what we consider to be a right circular cone because the vertex is directly over the center of that circle. And again, when you think about an ice cream cone or you think about a birthday hat, those cones are right circular cones, where in these last two examples we do have oblique.